Floating in the cupola of the International Space Station, you see Earth as a fragile marble in the vastness of space. The blue oceans and swirling clouds seem both familiar and impossibly distant, a reminder of how small and precious our home truly is. From this vantage point, the boundaries that divide us disappear, and you can't help but wonder what lies beyond the horizon, what new frontiers await humanity. It's a powerful reminder of how much there is to explore. The universe stretches out in every direction, filled with mysteries and possibilities that have inspired us for centuries. Each glimpse of the cosmos stirs our curiosity and our longing to reach further. For generations we've dreamed of reaching other worlds. Our ancestors looked up at the night sky and imagined walking among the stars, wondering if we could ever visit those distant points of light. We took our first steps with Apollo, setting foot on the moon and proving that we could leave our planet behind. Since then, we've lived and worked in low Earth orbit for decades, building the International Space Station as a symbol of global cooperation and human ingenuity. But the dream is to go further, deep into our solar system. We yearn to cross the vast distances that separate us from our planetary neighbors, to explore new worlds and push the boundaries of what's possible. Mars calls to us, a world that may have once been alive, waiting for us to explore its secrets. Its red deserts and ancient riverbeds hint at a history we're only beginning to understand, and the promise of discovery draws us ever closer. This isn't just about planting a flag, it's about expanding human knowledge and securing our future. By exploring other worlds, we learn more about our own, and we gain the tools to protect and sustain life for generations to come. To make these journeys real, we need more than bigger rockets. We need a new way to travel. The challenges of deep space demand innovation, creativity, and the courage to try what's never been done before. That next leap could be powered by the atom. Nuclear propulsion offers the promise of faster, more efficient journeys, harnessing the immense energy locked within the heart of matter itself. Nuclear-powered rockets promise to shrink the solar system, turning a 9-month trip to Mars into a much shorter sprint. This breakthrough could make regular missions to Mars, and even beyond, a reality within our lifetimes. Faster travel means less radiation for astronauts, more cargo, and safer, more flexible missions. It means we can bring more supplies, more science, and more hope to every journey. This technology could unlock the entire solar system, from Mars to the moons of Jupiter and beyond. Worlds that once seemed out of reach could soon be within our grasp, opening up new opportunities for exploration and discovery. The next era of exploration is within reach. With determination, innovation, and the power of the atom, we stand on the edge of a new chapter in human history, ready to take our next giant leap into the unknown. So, how does a nuclear-powered rocket work? What makes it so different from the rockets we're used to seeing launch into space? The principle is simple: heat a gas and shoot it out the back at high speed. But instead of using chemical reactions to create that heat, nuclear rockets rely on a completely different process. Instead of burning fuel, a compact nuclear reactor generates immense heat through nuclear fission. Atoms are split apart, releasing huge amounts of energy in a controlled reaction inside the reactor core. Liquid hydrogen, stored at extremely low temperatures, is pumped through the hot reactor core. As it passes through, it absorbs the heat produced by the fission process. The hydrogen instantly turns into superheated gas, reaching temperatures thousands of degrees hotter than what chemical rockets can achieve. This means much more energy is available to push the rocket forward. This gas rushes out the nozzle at incredible speed, creating powerful continuous thrust that can be sustained for much longer than a chemical rocket burn. It's not an explosion but a steady, efficient push, like a relentless wind that never lets up, propelling the spacecraft smoothly through the vacuum of space. The result? More speed, less fuel, and a rocket that can travel much farther than ever before, opening up new possibilities for exploring our solar system and beyond. Nuclear propulsion is a true game-changer for deep space travel, making missions to distant planets and even other star systems more achievable than ever. When it comes to space travel, the difference between chemical rockets and nuclear rockets is like comparing a speedboat to a sailboat. Chemical rockets have powered our greatest achievements so far, but they're limited by the very technology that made them possible. Chemical rockets burn through enormous amounts of fuel in seconds, creating a massive, fiery thrust that's perfect for blasting off from Earth's surface. This brute force is essential for escaping our planet's gravity well, but it comes at a cost, especially for long-distance missions. Their efficiency, measured as specific impulse, is relatively low. That means most of a rocket's weight is just fuel, leaving precious little room for anything else. This limitation restricts how many astronauts, scientific instruments, and life support supplies we can send on a mission to Mars or beyond. Every extra kilogram of cargo means even more fuel is needed, but nuclear thermal propulsion has the potential to change the game entirely. By heating hydrogen to extreme temperatures using a nuclear reactor, these engines achieve nearly double the efficiency of chemical rockets, resulting in much higher exhaust velocities and far greater performance. This means we get more thrust for every kilogram of propellant, making each launch far more effective and opening up new mission possibilities. With nuclear rockets, we could reach Mars in half the time, or carry much heavier payloads, enabling larger crews, more equipment, and more ambitious science. This flexibility means more opportunities for discovery, more robust missions, and the chance to establish a lasting human presence on another world. With nuclear propulsion, the dream of exploring and even settling other planets moves from science fiction to achievable reality. A human mission to Mars is tough, months in deep space exposed to radiation and isolation. Nuclear propulsion cuts travel time in half, reducing health risks and keeping astronauts stronger for Mars. Less fuel means more room for habitats, labs, and tools to build a lasting presence. Faster, more powerful rockets make missions safer and more flexible. If something goes wrong, a nuclear-powered ship can change course or return home quickly. We're no longer bound by narrow launch windows. Missions become more frequent and reliable. Nuclear rockets make Mars missions safer, more capable, and more practical. They're the key to building a sustainable future on another planet. The promise of nuclear rockets is huge, but challenges remain. Safety comes first. The reactor stays off until the rocket is safely in space. If a launch fails, the reactor remains inert, with multiple containment systems in place. Building a small, durable reactor for space is a massive engineering challenge. Rigorous ground testing is essential before any crewed mission. International cooperation and clear rules are needed for safe use and disposal. Overcoming these hurdles is as important as the technology itself. Picture standing on Mars, watching a new crew arrive from Earth in just months. Nuclear-powered rockets make this future possible, transforming distant worlds into reachable destinations. By heating hydrogen with a nuclear reactor, we double efficiency and cut travel time. We can bring bigger habitats, better tools, and the foundation for a permanent outpost. Safety, engineering, and global cooperation are vital, but the rewards are immense. Nuclear rockets unlock the solar system for human exploration. With this technology, we become a spacefaring civilization. The journey will be hard, but our spirit of exploration is relentless. The power of the atom will take us further than ever before.